And the reason for that is because we have so many ideas that we want to go pursue. AI makes it possible for us to go pursue those ideas now that we're not doing the mundane stuff. And so I think the first idea is...
Sit here.
The hot seat. Thanks for coming.
Thank you.
Great to have you.
Thank you. The #1 podcast in the world.
We were saying the #1 company in the world.
Wow.
Thank you.
Yeah.
You're a fan of the pod. You listen to the pod.
This is Norman, our host.
Yeah. Yes, and there's Steve. What's the story with the jacket? You got one of those? You have like 6.
I have something like 50 or 60 of them.
So
You really?
Yeah.
Wow.
what is that, Tom Ford?
I think so. This one is, I think so.
Yeah, it's nice. I like it. I tried that on. It was
Thank
like
you.
way too much money.
Well, you guys are all so fashionable.
Yeah,
Coming
right.
from you guys, it actually means something.
Yeah.
Oh, yeah. Oops.
Oh, look at you. Look at you.
Hey, we've been talking a lot about opportunity. You've talked.
Mine is like a model.
He is.
Okay, good. I
He's
quit.
definitely in his head. He's like,
Is Tom Ford your favorite? Who's your favorite? Right now?
My favorite is whatever my wife gets me.
She dresses you.
As soon as she gets it for me, it's my favorite.
Yes, same with me.
smart man. That's how you got up
Nobody
to the
wears
top.
a suit better than Jacob. Good God.
Yeah.
How does that
Jacob
happen?
is a handsome man.
Just trying to keep up with you guys.
I have 2 questions for you. Take them in whichever order you like. We've been talking a lot about job displacement, opportunity, short-term, long-term. Obviously, you get to see everybody applying the technology because, hey, listen, you've got the best product in town to build on. Therefore, everybody explains to you their hopes, their dreams, so you have a unique way of looking at the playing field. You have complete information that we don't have. So I want to know what you think. Don't worry, we'll fix it. What you think.
Can I fix that in edit?
What you think about job creation, transfer, displacement, et cetera. And then the second one, I've just always been curious. You got all these important people knocking on your door. You got Zuck, you got E, you got Sam Altman. He seems like he's a little bit of a headache, I'll be honest. But
He's great.
he's great. I'm joking. How do you allocate the H100s and whatever else you're selling them and still have them all like you? Because they must ask sometimes, hey, can I get extra? I'll pay you extra. So just the allocation of a finite amount of resources and then jobs.
First of all, I wrote off $5 billion worth of hoppers. If anybody would like to have some extras,
You got them.
just give me a call. Jobs. We use AI across our whole company. Every single software engineer today uses AI, not one left behind. 100% of our chip designers use AI. We are busier than ever. And the reason for that is because we have so many ideas that we want to go pursue. AI makes it possible for us to go pursue those ideas now that we're not doing the mundane stuff. And so I think the first idea is the more productive you are as a company, so long as you have more ideas, you could pursue those ideas. You'll go after those ideas. And I think that AI, in my case, is creating jobs. It causes us to be able to create things that other people customers would like to buy. It drives more growth, it drives more jobs, all that goes together. The other thing that to remember is that AI is the greatest technology equalizer of all time.
Okay, explain.
Everybody's a programmer now.
Yes.
You used to have to know C and then C++ and Python and, in the future, everybody can program a computer, right? Just have to get up. And if you don't know how to program a computer, you don't even know how to program an AI, just go up to the AI and say, how do I program an AI? And the AI explains to you exactly how to program the AI. Even when you're not sure exactly how to ask a question, you say, what's the best way to ask the question? And it'll actually write the question for you. It's incredible.
Yeah.
And so it's a great equalizer. Everybody is going to be augmented by AI. Everybody's an artist now. Everybody's an author now. Everybody's a programmer now. That is all true. And so we know that AI is a great equalizer. We also know that it's not likely that, although everybody's job will be different as a result of AI, everybody's jobs will be different. Some jobs will be obsolete, but many jobs will be created. The one thing that we know for certain is that if you're not using AI, you're going to lose your job to somebody who uses AI. Mm-hmm. That, I think, we know for certain.
Yeah.
There's not a software programmer in the future who's going to be able to hold their own, typing by themselves.
Yeah, you can't raw dog it, no.
No, not anymore.
No raw dog.
Not anymore. You can't raw dog it. And so
Tell us.
I'll be sure to go home and tell people,
Yeah, exactly.
"Hey guys,
That's
you're not going to
really-
raw dog this."
Yeah, get your co-pilot on. Now, what about the allocation of all these?
Okay, so the way we allocate is this. The way we allocate is this. Place a PO.
Okay.
That's
So
it. Just that's
you
it.
go to the register,
You pay, you get
order.
it.
First, in the old days with Hopper, it happened so fast. It wasn't possible to keep up with the demand. But now, we disclose our roadmap to all of our partners a year in advance. Gives everybody a chance to plan with us. They decide how much power and how much data center space and how much CapEx they want to allocate. We plan together, we work on transitions. It's really quite orderly these days.
What's the lifespan now? I was looking into how they're amortizing, these units 4 or 5 years. What happens to this massive build out in year 6, 7, and 8? What will be the use of those computers if you keep building such great products that replace them at 2, 3, 4 times? What do we do with all that?
Concepts are happening right now. The first thing is every generation we increase the performance by X factors.
Yeah.
If the perf per watt goes up by X factors, whatever your data center power is, we just increase your revenues by X factors.
Right.
So perf per watt is equal to revenues. Perf per dollar equals the cost. And so when we increase your perf per dollar by X factors, we reduce your cost by X factors. Does that make sense? That's the first idea. And so the reason why we're moving so fast is we're trying to increase everybody's revenues, we're trying to decrease everybody's cost so that we have the benefit of driving AI cost down as far as possible so that we can have thinking AI.
Right.
It's not that we're trying to make, AI so that it generates 1,000 tokens and that's it. In the future, you're going to be generating millions of tokens. And that generates an answer as a result of that. You got to think a long time. And so you got to get that cost down. The second idea is, if you look at the residual value of NVIDIA gear right now, Hopper, for example, 1 year later, it's probably about 80%, 75 to 80% of the value, of the original value. And then 1 year later is another kind of like 65%. And then 1 year later is like 50%. The reason, and right now, if you try to get Hoppers in the cloud, it's all sold out. The reason for that is because CUDA is so programmable, and we're constantly, the whole world, not just us, the whole world is doing open source development, improving its effectiveness. And so what's amazing is the performance of Hopper increases over time because we're improving the software stack. Hopper improved in performance by us and others by a factor of 4 in the time that we shipped it. Now, you can't get that out of a CPU.
Right.
Jensen, can you explain to us Elon's tweet and the impact to your industry? He said, we're going to have 50 million H100 equivalents in 5 years from now. And everybody started to feverishly do the math, because if he has 50 million H100 equivalents, then OpenAI will have that much or more, Meta will have that much or more, Google, et cetera, et cetera, et cetera. Can you just explain to us laymen what that means, what he just said, and how it impacts your business?
One of the biggest observations about AI is that there's the industry of applications that AI has created. It's a revolutionary technology. Every industry will be revolutionized. New applications will be created, so on and so forth. All the things that we know. Agentic AI, reasoning AI, robotics AI, so on and so forth. We know all those things now. Every industry, healthcare, education, transportation, you name it, manufacturing, all revolutionized. The one part that we observed and made a great contribution to is that in order to sustain those applications, you need factories of AI. You have to produce AI. Unlike software, you write the software and that's it. In the case of AI, you have to continuously produce it, generate the tokens.
Right.
In a lot of the same ways that energy production was a large part of the economy a couple, 200-300 years ago, I think it actually peaked out at 30%.
Yep.
There's going to be a whole industry of just producing tokens. And this is going to be the new infrastructure, just as we have the energy production infrastructure, we have the internet infrastructure, and we got to build out that plumbing. And now we have to build out the AI infrastructure. My sense is that we're probably, a couple of $100 billion, maybe a few $100 billion into a multi-trillion-dollar infrastructure build out
Per year.
Yeah.
What about manufacturing?
And the reason for that is because you want the new infrastructure, which increases revenue, drive your cost down.
Right.
That's right.
What about manufacturing in the U.S.? So where are we? We've seen stories of TSMC in Arizona. We asked this question earlier about how it's going. Is the U.S. equipped? What is it going to take for us to get there, to have onshore fabs?
First of all, you guys know you're talking about the United States. I know that there's lots of concerns and everybody's worried about competition and things like that, but we are talking about America here. This is unquestionably the most technology-rich country in the world, and this is the most innovative countries in the world. And the computer industry I have the honor to serve is the single greatest industry our country has ever produced. I think we could acknowledge that.
Yep.
The level of leadership of the computer industry, the technology industry, is just unimaginable worldwide. And so this is our national treasure. This is one of our country's assets. We have to make sure that we continue to advance it. Onshoring. Next generation manufacturing is going to be insanely technology driven. Robotics technology, AI technology. You're going to have factories that are going to be orchestrated by AI, orchestrating a whole bunch of robots that are AI, building products that are effectively AIs, right? So you're going to have this in layers of inception. And the amount of technology necessary to create that is really insane. I love President Trump's vision, bold vision, of reindustrializing the United States. That entire band of industry that's missing, we outsource too much of it, frankly. We don't need to insource all of it, but we ought to bring onshore the most advanced, the most economy sustaining, driving, national security enhancing parts of the industry. People always degrade down to tennis shoes. We don't have to go there. We just manufacture chips and AI supercomputers. In Arizona and Texas, we will, in the next 4 years, probably produce about $500 billion worth of AI supercomputers. That $500 billion worth of AI supercomputers will probably drive a few $1 trillion worth of AI industry.
Right.
And so that's only in the next several years. And they're doing great. Arizona's doing great.
And so there's a lot of talk about American competitiveness today, and the White House rolled out its AI action plan, and Nvidia is making very big bets on the United States. And so as a CEO of a global company, what do you see are America's unique advantages that other countries don't have?
America's unique advantage that no country possibly have is President Trump. And let me explain why. One, on the first day of his administration, he realized the importance of AI and he realized the importance of energy. For the last, I don't know how many years, energy production was vilified, if you guys remember.
Yeah.
We can't create new industries without energy. You can't reshore manufacturing without energy. You can't sustain a brand new industry like artificial intelligence without energy. If we decide as a country the only thing we want is IP, to be an IP only, a services only country, then we don't need much energy. But if we want to produce things, something as vital as artificial intelligence, then we need energy. And so I'm just delighted to see to accelerate AI innovation, to accelerate the growth of energy so that we can sustain this new industry and go after the new industrial revolution. Big deal.
Can you talk about physical AI versus data center AI? We talked a little bit about this today. Is there a threshold where you see physical AI accelerating and ultimately the deployment of chips outpaces the deployment of chips in data centers? Is that where the world evolves to, or what do you think
Everything in the world,
construction of the world looks like?
Yeah, excellent. Everything in the world that moves will be autonomous someday. And that someday is probably around the corner. So everything that moves. We already know that your lawnmower is going to, who's going to be pushing a lawnmower around? That's craziness. Unless you want to. I mean, it's, And so I think everything that moves will be autonomous. And every machine, every company that builds machines will have two factories. There's the machine factory, for example, cars, and then there's the AI factory to create the AI for the cars. And so maybe you're a machine factory to build humanoid robots. You need an AI factory to build a brain for the humanoid robot.
Right.
And so every company in the future, in fact, the future of industry is really 2 factories.
Yeah.
Tesla already has 2 factories, right? Elon has a giant AI factory. He was very early in recognizing that he needs to have an AI factory to sustain the cars that he has. Now he's got AIs in the car, but in the future, instead of, I imagine that in the future, instead of a whole lot of people remotely monitoring air traffic control, it'll be a giant AI that's doing the remote control. And then only in the case of the giant AI can handle it with a person come in to intercept. And so I think you see that these industries in the future, every industrial company will be an AI company, or you're not going to be an industrial company.
There was a couple of moments throughout the course of this year where people almost threw in the towel and said, "Oh, we lost to China," right? There was the DeepSeek moment. Then maybe last week, there was this Kimi model moment. But then it kind of fizzled out. Can you just explain to us how big of a threat they really are in terms of getting to supremacy, getting there first, to whether it's AGI or superintelligence?
Yeah, excellent question. The Chinese AI labs are the world's leading open model companies. They offer the most advanced open models. Open source is fantastic. If not for open source, we know startups won't exist. And to the extent that we believe that the future industry is going to be today's startups, they're going to need open source models. And DeepSeek, when it came out, it was a great win for the United States. It was an incredible win. What people did, and two reasons. First, imagine if DeepSeek came out and it only ran on Huawei. I just want us to pretend. Use that thought experiment.
Totally.
Right? Now you got 2 parallel universes.
No,
Exactly. Could you imagine if QN came out and it only worked on non-American tech stack?
Yeah.
Could you imagine if Kimi came out and it only worked on non-American tech stack? And these are the top 3 open models in the world today. It is downloaded hundreds of millions of times. So the fact of the matter is, American tech stack, all over the world, being the world's standard, is vital to the future of winning the AI race. You can't do it any other way. We've got to be, as you know, any computing platform wins because of developers.
Yeah.
And half of the world's developers are in China.
So speaking of developers,
The second
sorry.
thing, I'm sorry.
No, please go ahead.
The second thing, and it's really a big deal. When DeepSeek came out, we were thrilled for the second reason, which is we now have a super efficient reasoning model. And the reason for that is because the old models are one shot. You give it a question, everything was memorized. The pre-training is basically memorization and generalization, 2 concepts. Post-training is teaching you how to think. And so now with DeepSeek R1, Kimi K2, Q13, you now have reasoning models that help you think. And so the reason why I was so excited is if each pass of a thought is energy efficient, then you can think for a long time.
Right.
Yeah.
The last question from me is that we see this capital being applied to human capital in a way that we never thought was possible. It used to be NBA players signing $300 million contracts. Now it's model researchers. And then there was a post this weekend that said that there was a person that was offered $1 billion over 4 years by Meta. Now, if that's happening at this layer, why hasn't it happened at your layer? Because you are the enabler of all of that. And how do you think all of this human capital is going to actually play out?
First of all, I've created more billionaires on my management team than any CEO in the world. They're doing just fine. Okay, and so, and they're doing. Don't feel sad for anybody at my layer.
Yeah. Everybody's doing okay.
Yeah, my layer is doing just fine. But the big idea though is that you're highlighting is that the impact of 150 or so AI researchers can probably create, with enough funding behind them, create an open AI. It's not a
150 people.
Yeah, well, DeepSeek's 150 people.
Right.
Moonshot's 150 people.
Right.
Crazy.
And so, I mean, look at the original OpenAI was about 150 people.
Yep.
DeepMind, and they're all about that size. I think there's something about the elegance of small teams, and that's not a small team. That's a good sized team with the right infrastructure. And so that kind of tells you something. 150 people. If you're willing to pay say $20 billion, $30 billion to buy a startup with 150 AI researchers, why wouldn't you pay one?
Right.
Yeah.
Hey, speaking of options,
By the way,
somebody told me
we need to wrap because
yeah, no, but
we have the
I'm going to do
secretary.
this one
Okay.
question. Somebody who was inside your organization told me with the options that you have a secret pool of options, and that you will randomly just, if somebody does a great job, drop a bunch of RSUs on top of them, and that you have this like little bag of options you carry around, and that you give them out.
Nuts.
Is that true?
Yeah, I'm carrying it in my pocket right now. So listen, so this is what happens. I review everybody's compensation up to this day
Yeah.
at the end of every cycle when they present it, and they send me everybody's recommended comp. I go through the whole company, and I've got my methods of doing that, and I use machine learning, I do all kinds of technology, and I sort through all 42,000 employees, and 100% of the time I increase the company's spend on OpEx. And the reason for that is because you take care of people, everything else takes care of itself.
Yeah.
All right, well
Jensen,
done.
thank you.
Thank you, Jensen.
Great to see you.
Nice
Great
to
to
see
see you.
We have an
Good
event
job.
in LA. We'd love to continue the conversation.
Yeah.
So we'll send you a note.
This incredibly large demand for AI, and they're coming from, Sam and Elon are certainly the leaders, a couple of the leaders. There's a lot of demand elsewhere.
Nice to meet you.
Hi.
Well, thanks so much for being here with us today. We don't have a lot of time, so we want to get into it. In April, it was announced that you achieved your first silicon output at the TSMC facility in Arizona on that 2 nanometer line. This administration and the private sector have talked a lot about onshoring semiconductor manufacturing. Would love your thoughts of the on-the-ground experience in Arizona. How's it going? What's not going well? What does America need to do to get this right?
Well, absolutely. First of all, it's a pleasure to be here. Love the theme. I think we're all super excited about winning the U.S. AI race. And I thought if we're going to talk about chips, David, I should actually bring one.
Oh,
Awesome.
If that's okay.
Oh, yeah.
A little bit of show and tell. So this is our latest generation AI chip. It's our MI355 chip, 185 billion transistors. Takes about 9 months to build. Lots of technology on it. If I just
That's a 2 nanometer?
This is 3 nanometer and 6 nanometer. So lots of different
I'll be putting
chiplets.
this on eBay later.
I'm going to take it with me when I leave. How is that?
Thank you.
But look, to answer your question, I think, these AI chips are extremely, extremely complex. They have so much technology on it. We're super excited about the progress in U.S. manufacturing. I would say, 12 months ago, people weren't sure that we could do leading edge manufacturing in the United States. We've been very early in Arizona with TSMC, and we did get our first chips out. They're actually 4 nanometer. But what we see from it is where there's a will, there's a way. And I think all of the conversation about onshoring manufacturing has been super good for the semiconductor industry and frankly for all of us in semiconductors. We're in such an interesting place because chips are so essential to ensuring that we are able to win the AI race, that we want to make sure that there's a lot of geographic diversity and capability there.
But the reports out were that TSMC couldn't get good qualified, trained employees. They had to bring folks over. Is that accurate? And again, if we're going to scale, what's the order of magnitude we're going from here? Is it 10x, 100x? And how are we going to build a workforce to support this industry, which is a completely new industry for America?
And Lisa, you have permission to speak freely.
The best way to say it is, no matter when you start something new, it's going to take work, right? It's going to be hard. So sure, in the beginning, there were some issues of, TSMC has a formula for how they build, and they just rinse and repeat, and they've learned how to do that well in Taiwan. So they had to learn how to do it well in the United States. But I have to tell you, we've been super impressed with the progress. And if we look at the main thing that we look at is yields and just how many chips do we get out on a given wafer. And I would say it's equivalent between what we get in Taiwan and what we
about
get
cost?
in Arizona.
Because it's unrealistic to think the United States could compete on cost. Am I correct?
We're going to pay a little bit more.
Give us the ballpark. 50% more, 20%?
Not 50% more. I mean, look, it's going to be more than 5%, but let's call it less than 20%.
So low
double. Let's say low double digits.
And how does that impact the business, if at all, in terms of competition globally?
Well, I think the important thing is, just think about everybody wants a GPU, right? Like if you look across the industry, you really say, the people who are going to win in AI want to have as much compute in their foundation as possible, and they want assurance of supply. We want to be able to supply this no matter what happens. And so if you put that in context, the fact that you're not going for the lowest cost, every minute of the day, is okay. It's okay. Like obviously, we're not going to build. Not everything needs to be in the most advanced technologies, and so we have a very geographically diverse supply chain. I think Taiwan continues to be important in that view, but the focus from this administration on getting onshore manufacturing in a big way, not in a small way, I think is very good for the country.
How much time do we have if there was a disruption for whatever reason? We can come up with hypotheticals in Taiwan, and we were unable to get chips from those factories. What would that look like globally?
Yeah, you have to look across the supply chain, but from a structure standpoint, we all want to keep reserves for those times, but it's months, it's not years.
Lisa, there was two really interesting posts over the last couple of days. One was from Elon, where he said in 5 years he projected 50 million H100 equivalents just for XAI, and the second was Sam Altman. They signed a deal for a 4 gigawatt data center, $30 billion a year with Oracle. That just portends an enormous amount of chips that are necessary and power. And if you forecast that, how do we actually meet all of that? What needs to happen that's not happening today inside of the United States to actually do that?
Yeah, it's a great point. I mean, that's what we're seeing. We're seeing this incredibly large demand for AI, and they're coming from, Sam and Elon are certainly the leaders, a couple of the leaders. There's a lot of demand elsewhere too. I mean, if you think about it, nations want their own AI. So there's very high demand. We're imagining that just the accelerator market, so the chips for these AI large computing systems will be like over $500 billion in a couple of years. So very high growth. And when you say, what do we need to do? It's the entire ecosystem needs to scale up. So we need to scale up. Certainly what we're doing in chip design is trying to get chips out as fast as possible, but we're also scaling up the entire manufacturing ecosystem. And as I said, I think the US is going to be a huge piece of it. So it's not just about the silicon. There's all of the various other pieces of the ecosystem that have to come to the US. Sure. And I think today's AI action plan is actually a really excellent blueprint.
And how do you see the market evolving in these next 5 or 6 years? Is it there's a standard set of chips for training, a standard set for inference, or do you just see an explosion, like a Cambrian explosion of different ASICs, different designs, different use cases?
Yeah, I like that question because I am a believer in there will be diversity of chips. And the reason is there's so many use cases, right? If you think about use cases from, whether you're talking about science or manufacturing or design or back end or, frankly, personal AI, I think we're going to see AI in everything that we do, certainly in your phones and your PCs. And so you have all these pieces. You're going to have different types of chips that do that. Certainly for the largest systems, we tend to believe that you need the most compute you can get, and so GPUs are there, but lots of ASICs are in the process, and we'll see a variety of different chips.
You opened up a really interesting line of questioning there. When mainframes were so expensive, and then eventually wound up having PCs that were more expensive on their desktop, you alluded to AI being run locally.
Yes.
When would we have a local computer, a laptop, a desktop computer that would have the power we're seeing to run some of these LLM models in your mind? And do you see that as a specific market to go after?
Look, I definitely see the idea that AI will be at every part of our ecosystem is a real thing. I think that's one of the advantages. If you think about the power of AI, you want it everywhere, and you want it across all different applications. And I think when you think about PCs today, we're putting significant amount of AI in them to run local models. And why would you want that? It's like, well, maybe I don't want all my personal data all over the place.
On that point, can you make a prediction on when the market for physical AI chips is greater than the market for chips in data centers?
That's a great question. I'm a big believer in physical AI. I still think it's, let's call it 5 years.
You think 5 years? Is that fast?
It's at least 5 years.
So you're saying 5+?
5+, yes.
Yeah. Okay.
But that is ultimately the biggest end market. Do you think? Do you think physical AI becomes the biggest end market?
I think it becomes a significant end market. I think you look at chips in data centers and you look at chips at the edge, they're also significant markets.
Mm-hmm.
When you look at the most cutting edge techniques today, EV lithography, all of this whole stuff to make chips, one of the things that's observable is we're only as good as what humans have been able to invent. And I often ask the recursive question, what happens when the AI is able to invent its own method of manufacturing? Different material sciences, different approaches that we may not necessarily understand. Is any of that R&D happening, whether in AMD or in other places? Like, how are we trying to get beyond the physical limits of electrons shunting across a junction?
I think this idea that the AI can be extremely smart and extremely capable, like we think about how AI can design the future chips, and it will design pieces of it, but there's still a creativity of bringing it all together that I think humans are still absolutely at the center of that. So I don't necessarily see the AI designing our next generation GPU,
Right.
But I do see it helping us design the next generation GPU much faster and more reliably. So
you talked about the need to like reshore more parts of the sort of ecosystem. Obviously, you're sort of world-class at chip design. The fabs are getting reshored. But how do you think about things like lithography? Like, does that need to be sort of reshored, or like does ASML need to start building sort of machines in the United States, or is it okay to have that type of supply chain risk on an ally?
look, I think we have to accept the fact that it's a global supply chain. Like, even if you were to reshore X number of components, you would still have Y components that are across the world. I think it's important for us to have our allies together, so that's a key piece of the conversation, and ensuring that we have access to the latest generation technologies, and that is something that we protect given our intellectual property.
And going to first principles and asking you the open-ended question, what should be done about American education? I'm going to ask this a lot today. Assume there's no college, high school, nothing. You arrive in America, the situation is what it is today. What do you do? How do you build an education system to prepare the next generation for the evolving workforce? Yeah, I'm probably a little bit biased, as maybe some of your guests are today. I'm a big believer in science and technology background as being sort of the STEM background is so helpful when we think about the future workforce. And the earlier we can get into the sort of the process, I think the better. So some of the work that's being done to kind of revitalize the curriculum, I think is pretty important in the sort of the next generation workforce. And one of the things when I think about how we win in AI, like there's so many aspects of it, but ensuring that America is the best place for AI talent is also a key piece of that. So kind of inspiring people when they're young to really study science and technology.
Lisa, when you go to bed at night and you think about the best case scenario for this technology and this trajectory we're on, which is accelerating and you're enabling, what could the world look like in 10 years? Let's say, pretty obvious we're hitting artificial general intelligence at this moment. I think we'd all agree we're starting to see that. But super intelligence can't be far behind that. I assume you agree with that. Assume we hit that super intelligence. What would the world look like in 10 years in the most optimistic scenario if we do this right?
Well, I think the exciting part about it, and I can say this very sincerely, I mean, this is the most transformational technology sort of in our lifetimes. I mean, that's the way we should think about
Orders
AI.
of magnitude.
Orders of magnitude. And the reason is it's not just going after one aspect, right? You can actually take AI and make science better. You can take AI and make medicine better. You can take AI and make manufacturing better. You can take AI and make every aspect of your business better. And so, in my mind, 10 years from now, we'd like to believe that we are really leveraging it to solve some of the world's most important problems. I like to say, AMDers get up in the morning and they say, how can I use technology to solve some of the most important challenges in the world? And, AI is really our mechanism for doing that.
I have a business strategy question. If we went back 20 years and we wrote the tale of three companies, Nvidia, AMD, Intel, and then you fast forwarded 20 years, two have just absolutely thrived, and one has not. And if you had made the bet back then, it would have been very inconclusive that you would have picked Nvidia and AMD. And if anything, there was an amount of inherent belief that Intel had just figured it all out. Can you just tell us sort of like the lessons learned of why you thrived and maybe what you take away from their journey that you make sure AMD doesn't play out?
Well, as a CEO, we have to be paranoid every single day, right? So we don't rely on the past, but I think there are lessons of the past. And I think that probably the most important lesson that I can say for technology is you have to shoot ahead of the duck. Like you have to be thinking, what is the most, like your question, Jason, great question. We think about that all the time. How do we shoot ahead of the duck? And, you have things that change. Technology is a beautiful place because you see big inflection points. Like 5 years ago, AI was around, but we wouldn't be able to gather this audience to talk about AI because people would be like, who cares? But the fact is you had to invest many, many years ago to be where we are today. And I think, I like to say that you will be able to judge whether we've done a good job or not by how we perform 5 years from now. Like the decisions we're making will take 5+ years to play out. But that's the key thing in tech. Like nothing is fast, but hopefully it's quite lasting in what it can achieve.
What do you think is happening in countries not in the United States? Like what do you think is happening in chip design and all of these capabilities in China and other places right now?
We should believe that it's super, super competitive. I mean, at the end of the day, I think the world has recognized that that semiconductors and chips are essential. They're essential to national economies. They're essential to national security. And so assume that everyone's investing. I'd like to believe that we have a great head start, because of the innovation pipeline, because of the great companies that we have here. But we should not be confused that everybody's investing, and we need to keep up our investments as well. And I think that's why this whole idea of any one company can provide every solution that's necessary just isn't the case, right? I love the idea of open ecosystems, of companies collaborating, of collaboration across the ecosystem. So hardware, software, systems, collaboration across public-private partnerships, because that's what it's going to take. Like for us to win, we have to be front-facing and realizing that bringing the countries that win bring all of the smartest people and the best capabilities together and let them go as fast as they possibly can.
Great. Well,
Really.
Lisa, thank you for being with us.
Wonderful.
This afternoon.
Yeah.
It's been great. Appreciate it.
Thank you. Thank you.